These are the notes for Unit 10, Day 3. These notes, the first couple ways we're going to evaluate functions, you're going to notice, should seem pretty easy. It's going to be looking at a chart, looking at a graph. Then we're going to evaluate a function by putting a value into it. So really what we're going to do is we're looking at the value of the function given an input. So what you'll see is they give us a chart of values here, right? These are the x values. And f of x and g of x are just two different names of functions. So you'll see that we'll use f of x, g of x, h of x, j of x, k of x. We'll use different things. They're just saying these are two different functions. Maybe they're on the same graph. So like, for example, when x is -3, f of x is 13, g of x is 11. So they just happen to be different values. So all I'm going to do for this first one is I find out at -3 that f of x is 13. So my answer here is 13. So what that really means is when I plug 3 into the function f of x, I get out 13. All right. Now, if I go to -2, all right, -2, my function is at 8. Okay, so that's my answer right there. So when you plug in -2, you get out -8. And finally, we'll just do one of these g of x's. So g of x, a g of 3, excuse me. So at 3, where is function g? So you have two choices there. At 3, f of x is -10, but we're not concerned about f of x. We're concerned about g of x. So two different functions, we're going to get different values. Now, at the bottom, it asks, where are these functions equal? When we're asking where they're equal, we're looking at where do they share the same y value. So if you look, they share a y value of 3. And if I just go down the list, I don't see any other places where that happens. So that happens at -1. Now, the way that I'm going to write that is I don't just say x is -1, right? When x is -1, both functions are at 3. So that's actually a point. Each of these can be expressed as points. Now we can also look at a graph. So again, here I go to my function. I have my blue function f of x, my red function g of x. And the first one I'm going to look at is f of -8. So I go to -8 on the x-axis, and I go directly vertically to my f of x function, which is right there. And that appears to be also at 8. Okay, so what I could do here is I could say that is the point, that is the point -8, 8, and that's what I'm looking for. What is the y value when the x value is -8? So that is +8. If I go g of -3, I go to -3 on the x-axis, and I go directly to where my function is at -3. That would be this point right here. And I follow that over, and it looks like it's at -7. Okay, I'm going to give you these to be nice points. So if you don't see like a nice integer point, you might have missed something. Now, 0 can be a little bit tricky because we're talking about 0 on the x-axis, which is right there. So we're going to go directly to our red function g, which is down here at -2. All right, now the point where they are equal, we're going to answer that same question. Let me get rid of this just to get rid of some of this clutter. We want to look at where they intersect. So you'll notice we have a point of intersection here and here. So we just want to name those points. So that is 1, -1, and then -2, 2. So there are 2 points where they intersect, and that is where the functions are equal. Okay, kind of like when we did our graphing with systems of equations. Now, when we're plugging in values, these get a little bit trickier. So what I'm going to do here, I like to label these with colors. So I have 3 different functions, right? So I said that when we put f, g, or h, we're just denoting different functions. So what they're saying for 15 is when you plug 3 in for x into the function h of x, what output do you get out? So I'm going to use h of x, which is x squared plus 5x minus 2. And I'm going to replace those x values with 3's. That's it. Okay, so that is just an instruction. H of 3 is just an instruction. They're telling me to replace every x value with a 3. So I just evaluate that, right? So 3 squared is 9, plus 5 times 3 is 15. So it's 24 minus 2. So the answer there is 22. So you plug a number in, you're going to get a number out. Now the rest of these are just different instructions. So now they're saying plug 13 in for x in that f of x function. F of x says 2x plus 9. So I'm just going to replace that x with a 13. And I just follow my order of operations. So negative 2 times 13 is negative 26 plus 9. And then I'm going to get negative 17 there. That's it. So really just pay attention that you're plugging it into the right function. Be careful when you evaluate these. Follow your order of operations. We're not going to get super complicated. On the last one here, we're going to have 5x plus 1, right? And we're going to replace that x with a 7, okay? If this is a nice perfect square, which you're going to see right here, we're going to get 35 plus 1, which is 36, so we get a nice perfect square. I'll leave instructions as far as like what to do. If this was, the square root of 40, I would have you simplify that radical. Okay, so you plug a number in, you get a number out, just pay attention to the right, which thing you're plugging it into. Now we can also, and this is going to be important when we talk about composition, you can take this function f of x and you could plug something other than a number in there. So what I'm going to do here is I'm going to replace this x in negative 2x plus 9 with this x plus 3, okay, which is weird, but that just represents, a variable, some number. And now I'm not plugging out in a number to get out a number. I'm going to plug in an expression, and usually I'm going to get out an expression. So I'm going to distribute that negative 2. So I'll get negative 2x minus 6 plus 9. And now I'm just going to simplify this the best I can. I can combine those two terms. So I'll get negative 2x, oops, lost the x, plus 3. And that is the best I can do there. So when you plug in a number, you're usually going to get out a number, as you could see in 15 through 17. When you plug in an expression, you'll get out an expression usually. Thanks for watching the video. We'll do the